Hey everyone, let's start with question number 10, Digital Electronics asked in GATE examination 2025 instrumentation branch. A dual slope ADC has a fixed integration time of 100 milliseconds. The reference voltage of the ADC is minus 5 volt. The time taken by the ADC to measure an input voltage of 1.25 is. So before starting this question, I will recommend you to have a good explanation of the dual slope ADC, because in recent past year so many questions were asked on this topic based on different types of derived formulas. So although this question takes only 30 to 40 seconds to solve, but I will not directly solve this question. I will provide you the complete concept on dual slope ADC, so that you can in future can solve any type of question based on dual slope ADC. Let's start with the main components of ADC. Although also I will break this question on two parts. In first part I will explain you the complete concept and mechanism of ADC. Then after, in second video, I will give you the solution of this question. Let's have the most important part is main components. Main I will write here so that you can have notes on this topic. Main components. First one is your integrator. The second one is your comparator. Third one is your AND gate. Fourth is your up counter, which is of n bit. And fifth is your negative edge triggered T flip-flop. This is your flow of working. Let's understand what is the mechanism behind this. We will start first with the values of VA and V references. So first point is your important point is VA, which is referred as applied voltage, also known as input voltage. And your second is your reference voltage. One thing you should keep in mind, that this is your positive value and this is your negative value. So from now onwards I will write V reference as like minus of V reference, like -5, -4, -3, so that this writing this would be easily explained in derivations in upcoming topic. So I will write V reference as minus of V reference, which means V reference is your positive value and the complete is your negative value. It is a very small part, but sometimes so many students find it confusing and put the wrong values. I hope this much is clear. Now let's start with integrator. Integrator is is consists of R and C. Based on this, the expression of an integrator is can be written as V out is written as minus of RC integration 0 to T V of tau d tau, or I will recommend to write as V of epsilon d epsilon. This is an integrator expression, and the comparator compares the values. This is your V out here, V naught of t, and the comparator compares this value and this value, and based on which one is higher, it will give the output as logic 1 or logic 0, which will allow the clock pulse to pass from AND gate. When it is logic 1, the clock pulse will arrive here, but when it is logic 0, so the output will be 0 and the clock pulse will not arrive. So based on logic 1 and logic 0, the clock pulse will arrive to the counter. So as soon as the counter gets the clock pulse, it counts from 0 0 0 up to, let's say, 1 1 1 1. And assuming that it is an n of 4 bit counter, so values goes from 0 0 0 to 1 1 1 up to 1 1 1. Then again it starts going to from again 0 0 0. That's the working of the an up counter. One important thing you should see, that the MSB bit of the counter is connected to T flip-flop, which is a negative edge trigger. You should understand the T flip-flop will toggle its state from applied voltage to the reference voltage only when the logic signal goes from 1 to 0. This is means of negative edge trigger. As the logic of MSB bit goes from 1 to 0, this control signal triggers the clock and it is at toggle state 1. So whatever will be the value, it will toggle to the different state. So before toggling, the present state applied at this point is applied voltage, and when it toggles it, the input voltage applied is minus V reference. Currently the input voltage is applied voltage and before toggling the state. So let's come back to the integrator part, and I will give you much better explanation by solving the equations. V naught of t is minus 1 over tau. I will represent RC as tau, integration 0 to t. V of, for the ease of comfort, I will write as V of t dt minus 1 of t. When at starting I will write V of t is your applied voltage, which is a positive value. So I will take out that V of VA and integration 0 to t dt, which will give you minus VA over tau t, V naught of t, and plus constant. It is a indefinite integral. So if we see that if we don't apply the voltage, so V naught of 0 comes out to be 0, that at time t is equals to 0, there should be no output. At the output of the integrator, there should be no output at time is equals to 0. We know that this is this boundary condition. I will put this boundary condition in the above equation and I will get the value of C. C comes out to be 0 and your equation is V naught of t is minus Va over tau t. So this is your first equation which represent like y equals to mx. So your slope is minus Va over tau. I will now draw the same for plot. You will get a clear picture of by using the plot. This is your first point. This is Va by tau. This is your line, and this point is your P, let's say, and this is the time up to which an integrator is going to integrate the applied voltage Va. You should remember that it becomes T1, which is I referring as T1 time, which is nothing but 2 to the power n Tc. How this 2 to the power n Tc, I will come back to it. So if you write that if x-axis is T1 and y-axis comes out to be, put the value at T1 minus Va over tau T1. If you put the value T as at T is equals to T1, your output will becomes V naught of T1 is minus Va over tau T1. Your point this is T1 comma minus of Va over tau T1. Now coming to 2 to the power n Tc, how T1 is 2 to the power n Tc, and I am going to tell you that this part of time is always fixed. How? But it is a very important point you should remember. Let's start. As soon as this value comes out to be negative, because you can see that Va is a positive quantity, tau is your positive quantity, and t is also your positive time coming to be increased. So the overall value going to be negative. So V naught is comes out to be negative here, and this is your ground. So comparator output will be non-inverting, and which is logic 1. That means clock signal will be supplied to here. If up counter gets the clock, so it counts the value from 00 to 00001 at it takes 1 Tc clock time period of a clock. Again for the next 10 again 2 Tc, because the integrator is going to integrate, and the negative value going to comes out to be higher and higher in magnitude. So it is always going to be, for an example, minus 2 to goes to minus 3, then it goes to minus 4, and so on. So this part is going to be negative all the time, and the output voltage will be 1 because non-inverting is greater than inverting. Once the counter starts, as I say, it goes from 000 to 0001, 0001 to 0010, and so on up to 1000. It takes a Tc. Now again, if you go from 0, if you see that it goes from 0001 0111 to 1000. At 8th clock pulse, your MSB bit changes from 0 to 1. But what I said, that MSB bit will change from 1 to 0, then only the VA changes to, this key value changes from VA to minus V reference. So we have to see at what value this MSB goes from 1 to 0. It is the only one value which is when that counter goes to its maximum 1111 at 15th Tc, and then at 16th clock pulse it goes from 1111 to again 0. So look at the MSB goes from 1 to 0. As soon as MSB goes from 1 to 0, the T flip-flops triggers the value. So until this value, the integrator gets the same input as VA. So this line does not change until time is equals to T1 at 2 to the power n Tc. If you see that 16 Tc is nothing but 2 to the power 4 Tc. So what you get from here is at the time of integration, input voltage the time of integration is fixed. So I will write at input voltage VA, at the time of integration at input voltage VA, the time of integration is always fixed, because you can see that it only depends on the counter bits size, not on the value of VA. No matters what is the value of VA, it only depends upon the counter, because counter is going to from highest to lowest only when from 1111 to 0000. Then only the value goes from 1 to 0. There is no other step in between that goes from 1 to 0 of MSB. This is your important point. It only depend upon number of bits in up counter, that is n. I hope you got this point. That's why T1 is your fixed time, and that's what is known as integration time when VA is applied, and this is also same written in your question, fixed integration time of 100 millisecond. This is nothing but your T1 time, which is 2 to the power n Tc. I'm not solving the question, but I am explaining what is written in the question, each and every step. Now coming back to the integrating part. Now what we have done, we have analyzed the integrating part. Now we have to go further for this part. As next, when the T flip-flop triggers the value, it gets minus V reference. Integrator will get minus V reference as an input. So until we will write the equation, V0 is your present value VA into T. I will write as VA into T divided by tau. This is your present voltage, plus now your integrating is from T1 to T V of T dt. This is your value up to which the integrator has integrated the value for applied voltage VA. Now it gets the input as minus V reference. Now I am writing at VA divided by tau, plus I will write this as minus 1 over tau. I will write Vt is nothing but minus of V reference. I am taking integration T1 to T dt. This can be written as minus V over tau. This minus and this minus gets cancelled out. It becomes V reference divided by tau gets T minus T1 plus C V0 of T. You can read this expression as V0 of T is nothing but V0 of present plus future value. So your present value, which is due to the applied voltage VA, and now your future value is going to add up due to minus of V reference. Now this is your complete expression. If you put V naught of T1, as you know, I think so it is written should be as T1. I have done this mistake, sorry for this. This is the voltage up to it is it is integrated. So I will point this so you can see here. I will take a box on this. You can see here V naught T1 up to this point, up to in graph up to this point, it is taken the value of minus V over tau T1. This is your value. Now at V naught at T1, you know the value is minus VA T1 over tau, which you can write as this complete minus VA T1 over tau plus V reference over tau T minus of T1 plus C, and you have to write here as T1. So this gets cancelled out, this becomes 0, and this quit cancel out, so C becomes 0. So your final expression for your next part is V reference over tau T minus T1. This is your equation for this part. So this straight line says that your slope is V reference over tau. V reference over tau. You can again find this same equation and can cross verify it. You know this point, you know the slope, you can write the equation of this line, you will get this same expression. Now further going up, what happens at this point? At this point, it shows that V naught of T again has to become 0 in order to stop the counter and get our desired output from these lines. So when is this point comes, then when this point is going to come, you have to see that what you are basically doing. You have a negative value at the starting, you have some negative value accumulating, let's say minus 1, minus 2, minus 3 and so on up to let's say minus 5. This is the value you have accumulated at the starting when VA is applied. Now you are accumulating it over at 0.1 volt, 0.2 volt and so on up to which the whole sum becomes 0 volt, and as soon as it crosses the 0 volt, let's say 0.1 volt, the whole sum becomes 0.1 volt. This means that inverting terminals becomes greater than non-inverting, and your again output becomes logic 0 and the clock will not pass, which means the bits which were present here will be your digital output of your corresponding analog input. So I hope you understand. I will repeat this once again. This is your negative value which starts accumulating minus 1, minus 2, minus 3 up to minus 5, and it gets stopped and the voltage gets triggered from VA to V reference. Now positive values start accumulating on this negative value. The whole sum is going to be 0 at one time, and this is that time which I am talking about. At this time the whole sum will become 0, and as soon as it crosses 0, that is 0.1, the inverting terminals becomes greater than the non-inverting and the output becomes 0, logic 0, and the clock signal will not be applied to the counter and counter will stop and the bits which will be available at the MSB and LSB of the counter will give you the output of your corresponding. This will be your digital output of your corresponding analog input. So we have written this equation, and the most important part is what we have derived, that boundary condition of V naught of 0 will become 0 when at, or I will say V naught of 0 will become 0 at t is equals to 0. This is your one condition which you can put and satisfy it. Now your second condition was V naught at t is equals to t1 plus t2, which is I am showing at, this is now your time t2. What is your complete time here? Nothing but t1 plus t2. Now putting this value, and we will get the output as 0 at t is equals to t1 plus t2. If we put this value, we will get minus VA t1 over tau plus V reference over tau t1 plus t2 minus t1. This will cancel out. Tau will also get cancelled down, and we will get VA t1 is equals to V reference into t2. This is your equation, the most important equation which will answer the above question. You can also find this equation by one more method. I will tell you that find what will be the slope of this. You can see I am writing here, please be focused, that what is the slope of this is written as V reference over tau, which is equals to change in y over change in x. What is the change in y value? Change in y is minus VA t1 over tau, and change in x is t2. So tau gets cancelled out, and you get t2 V reference is equals to, and this is your change value, so you can take it as positive, VA t1, and you got the same equation here also, the same equation. I hope you got a good clarification on this. If I want to add more on this, I can tell you that no matter what will be the value of your VA, only it affects the slope. If VA is small, your slope will change, but your T1 will not change. I am repeating again, will be always fixed. And if VA is this, then it is always fixed at, if VA is large, but time will not change. What will happen? The output voltage will change. So your important equation, I would tell you that this one and this one and this one. Now I will discuss the solution of this question in the next video I have taken in two parts. So I will tell you in the second part of question number 10 solution. If you have any further query, you can ask in the comment section. Thank you.